My name is Professor Jom-Gi Beck, and I am Professor of Marine Technology in the Department of Mechanical Engineering at University College London. Today, I would like to share some perspectives on transformative technologies shaping the next century of the maritime sector. This lecture focuses on foundational and overarching concepts, rather than specific products or short-term trends. My aim is to step back and explore how emerging technologies, systems thinking, and new engineering philosophies may reshape maritime systems over the coming century. I hope this talk will offer a conceptual framework for thinking about the future of marine technology, one that emphasizes safety, sustainability, resilience, and human-centered design. Before we talk about technologies, we must understand why the next century of maritime development truly matters. Shipping is not just another industry. It is the backbone of global civilization. More than 90% of global trade by volume moves by sea, sustaining the world's food supply, energy security, and industrial production. What makes shipping fundamentally different from many other sectors is the longevity of its assets. Ships are not short-term products. They are long-life, socio-technical systems designed to operate for several decades in continuous interaction with harsh environments, evolving regulations, digital technologies, and human operators. For over a century, maritime engineering has been guided by three enduring pillars: safety, sustainability, and cost-effectiveness. Today, these pillars are under unprecedented pressure. Nowhere is this more evident than in decarbonization, where the International Maritime Organization has set a clear ambition of achieving 100% zero-emission shipping by 2050. This means the next century of shipping cannot be shaped by incremental change. We are entering an era defined by artificial intelligence, digital twins, ultra-low latency communication via LEO satellites, and increasing autonomy. The ships we design today will operate in a far hotter, more uncertain, yet more connected world. If we step back and look at the last 150 years of maritime history, a very clear pattern appears. Shipping has evolved through a sequence of major technological leaps, from steam to diesel to automation and most recently, digitalization. These changes did not happen gradually. Roughly every 50 years, a disruptive technology emerged and reshaped the industry. Each leap fundamentally changed how ships were designed, operated, and regulated. Importantly, every transition reshaped three things at the same time: safety by introducing new risk profiles, labor by redefining crew roles and required skills, and economics by transforming efficiency, costs, and global trade. The key lesson is this: these transformations were never purely technical. They were systemic. New technologies demanded new regulations, new training, new organizational structures, and new ways of thinking about responsibility and risk. This is why history matters. It tells us that what we are facing today is not another upgrade. It is another system-level transformation. And the industry that understands this will lead the next century of maritime engineering. For more than a century, ships have been designed primarily for construction and certification, not for lifelong operation. We design, we build, we certify, and then we largely wait for failures. When something goes wrong, we inspect, repair, and return the ship to service. This inspect after failure paradigm served the industry well in the past, but it is no longer sufficient. Today's ships operate in a highly dynamic world, exposed to extreme weather, long-term aging, variable loading, and increasingly complex operational demands. Yet our rules and standards remain largely static, frozen at the design stage. At the same time, we still treat structures, machinery, human operators, and the environment as separate domains, even though real ships operate as tightly coupled systems. Modern accidents rarely originate from a single failure. They emerge from interactions across these boundaries. Conventional engineering has not failed. It has simply reached the limits of what it was designed to handle. For ships expected to operate safely and sustainably for over 50 years, a fundamentally new paradigm is required.